Hey everyone, this is Mr. S, and today we're going over the readings for Lesson 8 in case you want to read along with me and follow along. Okay, so Lesson 8 reading sheets. Can a systems comparison help us understand what happened to the buffalo and wildebeest between 1975 and 2000? So here you have graph A, so you're going to interpret that. Make sure you look at the year and see how the population increased and then decreased at a steady rate. And then here's the wildebeest population from 1958 to 2000, and look at how it went up and stabilized. So you can compare these two and look at them. And then I'm going to read this reading out loud and kind of highlight it, so follow along with me, okay? The African buffalo respond strongly to variation in rainfall. So I would probably highlight that. Through the effect of rainfall on forage availability and quality. Extreme food scarcity during severe droughts are often associated with massive die-off of large numbers of grazing ungulates in African savanna. This just means hoofed animals, okay? Like cows, sheep, etc. For example, the severe drought of 1993-4 killed between 14,448 out of 36,119 buffalo and 250,000 of 1.5 million wildebeest in the Serengeti Park. So we can say a severe drought. Hence, recurrent severe droughts in the Mara Serengeti, competition between buffalo and other herbivores, including livestock, plus major land use changes in the pastoral ranches of the Mara, may exacerbate these effects, increasing the susceptibility of buffalo to food scarcity and delaying their population recovery even after forage supplies have improved. So there we go, competition between buffalo and other herbivores. Major land use changes. Exacerbate means make worse. So that's making worse this problem of droughts already. That's already happening. The buffalo counts between 1984 and 2010 show that the buffalo population growth rate in the Mara was significantly related to the prior density of buffalo population and the amount of dry season rainfall the previous year. However, the changes in buffalo numbers were not significantly correlated with prior density before 1994, even though the droughts of 1984 to 95 occurred in the Mara during a period of high buffalo density. The significant negative influence of prior density on population growth after, but not before the 1993-1994 drought is surprising, because we expected the effect of food limitation on population to be greater at high density of buffaloes, not low ones. Okay, so that's a really important part. So I would highlight all that. So we're seeing that actually the density of buffaloes is when there were higher populations or higher densities of buffaloes, there was less effect of the drought, right? So that is something I would kind of mark and think about. The figure below shows total annual rainfall between 1965 and 2001. The line in the middle shows the highest average amount of rainfall when a bar goes above the line and means that the annual rainfall was higher than average. When a bar goes below the line, it means that the annual rainfall was lower than average. So here you can see everything above here was above average, and here the average annual rainfall was below average. So what does this tell you? Alright, and here we have reading B. Does competition regulate ungulate populations. Like further evidence from Serengeti, Tanzania. Remember, ungulate means hoofed animals. Scientists took blood samples from buffalo they immobilized or stunned in 6 different areas of the Serengeti in 1986. The proportions of animals from different areas of Serengeti that had rinderpest antibodies are shown in Table 3, along with the rate of buffalo population increase in the population. If rinderpest was the cause of the buffalo population in the last decade, then one should see larger declines in areas where there were higher populations of rinderpest. So that's really important. Make sure to review these highlighted spots. You can pause the video. A statistical test performed on the data shows no such relationship. Therefore, these results do not support the hypothesis that rinderpest was the major cause of decline in the buffalo numbers in Serengeti. And then Table 3 here, we have the numbers and frequency of buffalo in different areas of Serengeti showing positive antibodies for rinderpest. So you can kind of see here, these had the highest percentages, yet only one of them had shrunk in size. So the groups with the highest population didn't necessarily shrink in size. So make note of that. Finally, we have reading C, evaluating the protection of wildlife in parks, the case of the African buffalo in Serengeti. Buffaloes are known to be targeted by illegal hunters. Park rangers who actively search for snares and signs of illegal hunting have identified buffalo carcasses in the field, and buffalo meat appears in villagers' bushmeat diets. Illegal hunting remains a large threat to conservation efforts in the Serengeti, and therefore we determined whether illegal hunting was a contributing factor to the spatial differences in buffalo recovery. In 1977, anti-hunting activities were severely restricted by an economic crisis in Tanzania, and widespread hunting on this species and others followed. By 1992, anti-hunting efforts had returned, but the buffalo population had been reduced to 36, 119 animals, some 49% of the peak number. In the Serengeti, the human population is greatest in the west and northwest. The population is also increasingly more in these areas. For the buffalo, food limitation is most severe in the east and south. The rate of predation is roughly the same across the Serengeti. The researchers wanted to know whether predation from humans and lions explained the drop in buffalo population. Table 1 below shows what they found. So you have the region, the loss of herds, and the recovery post-1993 drought, and the death of buffaloes from hunting. So the researchers also reported that the amount of hunting was related to the size of the population in the regions. They also found that areas with lots of food for the buffalo in the north were not recovering as past. So I just want to point out to you that this has the highest rate of death from hunting, 31%, and also the largest loss of herds, and the lowest recovery from after the drought. So that is pretty convincing. The next largest group of death from hunting is 16%. And you can see that these numbers are also increasing. So where the deaths from hunting are the lowest, you had the best recovery from the drought, and the loss of herds was also much lower. So this is a convincing sign that it could be the hunting that was causing this. Okay, good luck.